Hi folks, welcome back to Physics with Captain Rod. Making this video to help you out with one of these problems here. We're going to take a look at number 13 on chapter 17, and what we've got is this kind of wheel looking geometry here, and it's made up of a ring of 10 kilograms. So this guy right here, 10 kilograms, and then a pair of spokes, each of these 2 kilograms. And then the million-dollar question, or what we've been asked to calculate, is the moment of inertia of this system about point A. Now, there's a couple ways to handle that. I think I would probably start with this. I'd probably start by calculating the moment of inertia of the system about this point right here, which I'll call that point P, or actually let's call this C. And then we'll apply the parallel axis theorem. Once we find that moment of inertia, it's pretty easy just to shift to point A. Now, I've already kind of went ahead and started this. This thing's got 4 different parts, like part 1, part 2, part 3. I'm going to give these names here. So this horizontal bar, let's call this bar 1. The vertical one, bar 2. Then this outer part here, maybe part 3. So the moment of inertia of this system is going to be the sum of 3 terms, which I've already written out. So let's take these one at a time. So I1. So this is the moment of inertia of this bar. Now this, if I treat this like a slender bar axis through the center, I would have 1/12 ml squared for the horizontal bar. For the vertical bar, it's the same thing. Another 1/12 ml squared. And then we'd have the hoop part. If you go ahead and look up the moment of inertia of a hoop, I'm pretty sure, I haven't looked it up, but I'm pretty sure we're going to get, I'm just going to put big M R squared here, where the big M is this guy. Then the little m is going to be the 2 kilograms. These can be added together. Now, the moment of inertia of this geometry about point A, we can get by taking the moment of inertia about its centroid, which is what I talked about calculating. And then we just have to tack on an mr squared term for the fact that the axis has moved over to here. Now the mass is going to be the total mass. So we got 2 of those little m's and 1 of those in the mass of the hoop. And then the distance is this distance given in the problem. I'll just put r squared there. So we've got a horizontal geometry, a vertical geometry taken into account here and here. The hoop taken into account here. And this expression therefore gives the moment of inertia of this entire geometry about its centroidal axis. Right? So that's what we just calculated. And then to take into account the fact that the axis is moved, we just need to add an mr squared term. Keep in mind that the m, though, needs to be the total mass. There's 2 of the little bars and then 1, and then the hoop. And then the r would be this 0.5 meters. So that's a pretty short problem. That should probably get you through that. Have a great day.